Good morning, good evening, good afternoon. I don't know if Ozzy's going to dump into my stream. I assumed that he was looking like that. So, what's up, Kaiser the Pineapple? First, good to see you, buddy. What's up, Impish, my dear? The lovely Impish. Thanks for all the help lately, and always. I was on time and straight, thank you. But nice try. You did. I saw them all and said, damn this, I'm going to be on time. What's up, Jacob? I'm working on that, Jude. I'm working on that. Trying to get balance with sound. What's up, Dazzer? 2 days on the trot on time. I know. It's like I told you, bringing some professionalism to it. But it has been a day, so I did not finish the new intro. So next week. Oh, the Demon Core is fascinating. We can certainly talk about that at some point. The problem is the government severely regulates plutonium. I've been looking for some, and it's just not going to happen. It's on time. What's up, I Am Princess? Good. Well, I think in all fairness, I think Ozzy was about to wrap up anyways. So, and I think that is everybody over here. Over on the Rumbles, which we're also streaming on, we have lovely Impish, the Pineapple, and myself. Interesting one Kaiser put over here. So how do I build a, quote, atomic device, unquote, asking for a friend, totally not wanting to build one? And my response to that was, Kaiser, that is next week. This week is the foundational science behind atomic theory, which, well, that's true. That's very true. No lies detected. It is. See, you can make it. So as my regulars know, I don't know where it is. As my regulars know, I have uranium, and to make plutonium, you just have to urac uranium. So I'm slowly building. You have to centrifuge, put in centrifuge, spin it for a long time at certain temperatures. I just want like 10 grams, like literally. I just want it for my collection. So you just spin it, enriched uranium, and then bombard it with neutrons. You split it apart. I have the zirconium rods. I have some heavy water, some deuterium. Like, we could make this happen, guys. It's totally a joke. FBI, CIA, NSA, Nuclear Regulatory Agency, whoever else is listening, UAEA. What's up, Stevie? Good to see you, buddy. Mystic, good to see you. Big Giant Fuck, what's up, buddy? I was hoping. Does anybody know if Ozzy is still live? Because by the way he was talking, I assumed he was waiting for me and then dumping here, but I could be wrong on that. Exactly. I said it very, he's wrapping up. Okay. I didn't say anything that wasn't freely available on the internet or general knowledge. I saw this, and maybe we'll start with this because we all know my affinity and love for rockets. So I thought this was really interesting and thought, why Why not? Why we're opening the show, maybe we'll take a look at it. So this is launch an explosion seen from a plane, so from an aircraft. So we'll watch this. I prefer bombardable U-235, but I mean, I'll take what I can get. I have uranium. Uranium's not as difficult to obtain. The plutonium is a bitch. But yeah, for sure. Under Fort McClellan. Yeah, that would be tough to get to, though. So here is the SpaceX Starship launch explosion is seen from a plane, as the title says. And this would be outside of the exclusion zone, but there would be a distinct. You would be able to see it without any interruptions. As you can see, it is right here above this engine to the right. Closer than I would have anticipated, but it is deserted? Huh. Well, uranium or plutonium is also highly toxic. As we see, we're getting up there. There's where it starts to spin. You can see the drop in the track. Terrible camera work, but you know, like it's all about framing. Get that thing in frame, please. Like they didn't. Not a lot of camera shake though. Oh no, you don't even show the. There it is. You can see the explosion, but they put their end card over top of it. Weitere Batterie jederzeit unerwartet. Turbulenzen auftreten können, bitten Sie Ihre Sitzgurte geschlossen zu halten. So I don't know where that was from, but I thought it was interesting. So, actually, let me just pull that down. So I thought that was an interesting clip. Your nose is not as big as yours, Ember. All right, so into this. So atomic theory is probably one of the most fundamental things in our lives. There's so much to the atomic theory of physics, and it's pretty important to our everyday life. So we'll go into. I hate end cards too, like, and yeah, it was a massive explosion. So, a lot of fuel, and then of course you had the FTS flight termination system that was intended to make it explode. So, they strap explosives to it to make sure that it's not harmful to people. Interestingly enough, the United States government is attempting to sue SpaceX. Well, I guess they are suing SpaceX, and attempting to ground all of their vehicles for the damage caused by the Starship. So, but we all know that's just purely circumstantial. Like there's no connection to politics there. So I don't even know why we're looking, guys. Yeah, it is. It seems very motivated, if you ask me. But so we'll see how they handle that. Obviously, they have a lot of contracts, and obviously they've made themselves a place where where there's a lot of need for their product and service. So I don't know that they can. I don't know that they can exclude him from being able to fly any spacecraft. For example, their only human-rated spacecraft that can make it to the International Space Station is currently the SpaceX Dragon. So, what are we gonna do? Go back to Russia? That sounds like a good idea. Like, let's go back to Russia and pay them exorbitant amounts of money for seats on a very old, albeit incredibly flight tested rocket. So yeah, he does. He has the scientists, he has the vehicles, he has the infrastructure. Falcon is about as routine as space travel gets. The record is impeccable. So all right, so into atomic theory. So I'm going back to the book. I was doing day shows with the science stuff and purchased a theory book, and it's been very helpful. So I start generally the shows by reading out of the book, and it has a 30-second theory, a 3-second thrash, and a 3-minute thought. Related theories and related persons. So the original atomic theory was proposed in the 5th century BCE by the Greek philosopher Democritus, who speculated that everything in the world was ultimately composed of combinations of small, hard, and invisible particles. He called the particles atoms and suggested they came in various shapes and sizes, but were all made of the same basic material. The modern scientific theory of matter states that a great variety of substances we see in the universe are made from combinations of these different chemical elements. These elements do indeed consist of trillions of identical subunits or atoms. The internal structure of an atom is specific to each element and gives that element particular properties and characteristics. Thus, a hydrogen atom is constructed differently from the atom of gold. Modern atomic theory kicked off at the beginning of the 19th century with the work of English chemist John Dalton. However, it wasn't until 1905 that Einstein proved the existence of atoms mathematically in his famous paper on Brownian motion. A few years later, Ernest Rutherford was the first to look inside atoms in an experiment in which he bombarded a thin sheet of gold with alpha particles. He discovered that every atom consists of a tiny positively charged nucleus surrounded by an empty space in which even tinier negative electrons orbit around the nucleus. The related theories are Brief History of Time. Stephen Hawking is my favorite book ever. I've read it so many times. It's a fantastic book, Jacob. So related theories to this one are quantum mechanics, the uncertainty principle, and quantum field theory, which is something we'll get into later. Again, I'm trying to. I actually haven't read Universe in a Nutshell. I'll look at it. So what I'm trying to do is to lay foundation. So we started with basic scientific theories to get us kind of kicked off. Now we're going into like atomic theory. And then we'll use atomic theory to propel us into both building nuclear weapons and then into quantum physics or quantum field. So we can start building fundamentally on things as we go. So a 3-second thrash. Deep down, everything in the universe is composed of the same set of building blocks. It's and we'll wait to get into quantums until we get into quarks, muons, that kind of stuff. The quote unquote God particle that really wasn't after it was found. that kind of thing. So we'll get into that a little bit too. And absolutely, I don't want to leave anybody behind. If anybody has a question, there are no stupid questions or nothing that I'm going to make fun of or, chastise you for. Ask your question. I love it. And I'll try my best to respond. And if I don't know, then I will certainly find the answer for you and get back with you. So our 3-minute thought. Today, atomic theory is much more than just a theory. It's an undeniable fact. It's close to law. Yes, Sleazy. I'm going to keep reading and I'll address your question. Not only can we see individual atoms using electron microscopes, we can even trap them and move them around using lasers. So when we talk about atomic theory today, we do not mean that the theory states that everything is made of atoms, but rather the theory that describes how atoms behave and interact. The realm of quantum mechanics. Yeah, I'm starting to figure that out. Well, he asked a question right after I said question, so he's just so this is more atomic propulsion than just atomic. So we're going to take fundamental atomic physics. So we're going to break down atomic structures and nucleus, a little bit of history, and some other things like that. How does atomic propulsion work in space? So that's a new field of study. There is significant investment going into that. There's two concerns with that. So one is reliability, and we haven't. So many people think that like a nuclear reactor is this big incredible technological achievement where they're breaking apart these atoms and converting it to electricity. And that's just not the case. We're basically making a chain reaction causing heat. Heat boils. The boiled water turns the turbine. So, that's awesome, Jude. I appreciate it. So all we're making is a heat generator. So like a radiothermal generator almost. So we're not even releasing the power into usable form. We're just heating water and doing it the way we've done it through hydro plants or coal or gas or whatever other medium. We're doing nothing spectacular. It's just a much more efficient way to heat water. So there's parasitic loss in turbines and stuff like that. Fission power is it's a simple heater. It's a heat exchanger that turns a turbine, makes steam, turns a turbine. So there's complexity in the rods because of safety and that kind of thing. But as far as the actual science behind it, there's more science behind the fuel pellets than there is the reactors, in my opinion. But so the second problem is launching radioactive materials into space is not something that world governments are really thrilled about. So it's not something that they're going to do. Now, the radiothermic or the radioisothermic generators, those are hard enough to get up, and the launch vehicles have to be blah blah blah, and like it's kind of ridiculous. So yeah, that's one of the things. So getting a launch license to launch nuclear materials into space is pretty difficult. So we'll use look at a couple of these. Science photo laboratory. Okay, so what is an atom? So we'll start with well, you know what? It would be better to do it with carbon. It's not even that. It's the tracking in the international treaties that give it that make that an issue. I wish it was that easy. A lot of governments have their hands in a lot of that kind of stuff. So, unfortunately. And a lot of people that don't know what the hell they're talking about have their hand in that stuff. So that doesn't make it any better. So actually start with the simpler atom, carbon. So this is just a graphical representation. They would also shoot it down and probably bomb it. It's not the sending it. So it's the risk of failure. Rockets still have a pretty high failure risk. So it's the risk of failure in raining hot radioactive waste over large swaths. So one of the things that we learned with the orbital tracks is they go over Earth for a vast distance, and if that explodes, it spreads just an enormous distance. Like it spreads, it spreads quite a bit. There's a large debris field from that. So when you're launching it and a rocket explodes or a rocket malfunctions, that debris pattern and then you add an explosion to something that's optimized to produce energy, so it's energetic, then you're blowing up radioactive materials over a large field of area. So it would be catastrophic to a lot of people. So not in the space. If we could just get it into space free go at it, it would be fine. But yeah, it's that midpoint where the reliability isn't there to take that risk. I like where you're going, but let's put a pin in that, and we'll. Seems like a lot of work, bro. So let's look at a carbon atom. So this is a basic carbon. It's the sixth element on the table. I should bring up. That would be a good idea. Let's bring up. Oh, that's a cool one. I like that picture better. Oh, where did it go? Okay, this is better than anything I found. So as far as okay, so we're gonna. All right, buddy, take time. Yeah, that's the issue. So, and there's also, like Jacob says, returning. So if you put it in a satellite for a power generation, they decay eventually, and then again you have large swaths of area that are radiated because of it, orbital decay, and carbon is the most versatile. We're carbon-based life forms, so carbon's great. So, unless you're a leftist, then we want to destroy all carbon. All right, so here's hydrogen, just so I can show this. Its atomic number is 1. We have 1 neutron, 1 electron. And it shows its atomic radius. This is very, very small, obviously. And then we can have variations. So you can have all these variations of this elemental hydrogen. So those are different variations in the electrons and energy states and blah, blah, blah. And I don't like that picture. See, this has, let's do this one, because then I don't have to go back and forth. So we have atomic number 1 and an atomic mass of around 1. So we can have a +1, so we can add a proton or an electron. And this is, hydrogen is the most common element in the universe, and it's the fuel that stars use. So you have hydrogen stars that turn hydrogen into helium via nuclear fusion. So this nucleus has immense amount of power. So then we have helium. So helium, we have the bonds of the protein, or the proton. We have 2 electrons, and our mass goes up to 4. And again, there's different charges that we can have, different protons, different neutrons, or different electrons, excuse me. So basically, your neutrons are these little green guys here. So a nucleus is always going to have the requisite number of neutrons. That's kind of what makes it the element. Protons can be added and make it a positive state element. Electrons can be added. When you're talking about nuclear chemistry or atomic chemistry, where's Brian? Electrons orbiting proton, like in different numbers. Yeah, exactly. And that would tell the charge. And the way that we utilize a lot of this is in chemistry. We're trying to, stability depends on how willing it is to shed some of these things. When you have something that really likes to catch fire or interact with a certain material, that's how willing it is to give off electrons. So I never liked chemistry much. I have much more of appreciation for it now, but I was never a big chemistry person. Mostly because they wanted you to learn everything, remember everything. So then we have lithium. It's the same thing. Now we're getting into electron shells. So it's not always just one orbital of electrons. You'll have electron shells. And lithium really wants to give away this, or bring one in to counterbalance it. It wants to be balanced. Here's carbon. So carbon is 6. This is the one we were talking about. And we have these 2 valences, covalences, and we have this bunched nucleus of protons and neutrons. Carbon is present in all known life forms. Pure carbon can exist as diamonds or graphite. Carbon is incredibly versatile. Yes. Electricity and outlet. So it's basically, and there's some debate on this, but you have magnetic fields moving electrons down a copper wire is essentially what you have. Human body is 65% oxygen. We have a lot of oxygen. Oxygen also really likes to burn a lot. Atomic number of 8. Well, it likes to help things burn. We all know oxygen. And this is like a worksheet. Here's a bunch of different elements. But I didn't want to go into chemistry too much because chemistry's for nerds like Brian. When we look at gold, this is gold. This is where we start really getting into large nucleus and a ton of electrons. I'm sorry, I'm just saying. There's been a lot of debate currently on it, so I wanted to bring up uranium because talking about it. Uranium's such a pretty atom. Not from the... Well, I guess that's probably a... So this is, for example, this is uranium. A lot more complex. So this is what you use in nuclear reactors. Yeah, I'll go back to gold. This is what you use in nuclear reactors. Highly energetic. And just fun. And you have all the different isotopes that can do different things. So it's just a pretty atom. And this is kind of the 2D version of it. So, and this is uranium-235. Yep. Because it crystallines more than... And that's some of the... So when you're looking at the 3D representation, they're not pretty and flat like this. They're more like that previous photo. That's why I wanted to show it. But this is generally the representation. So Silver's your personal favorite? I like silver. So this is much more like what they are, and you have these orbitals of free electrons. So where the hell did gold go? There, yes, gold. So this is gold. This is the rare one that people like. I like palladium. I have some palladium too. Good stuff. So here's your gold. Again, super stable. It's lithium. Seriously? Huh. That's cool. That's a different name. You wouldn't... So anyways, back to... When we get into nuclear fission, Again, we use this uranium-235. So we're not worried about our electron shell. We are worried about this nucleus. So we want these protons and these neutrons. And essentially what we want to do... Oh, is it really? Huh. That's interesting. So this is basically what we have here. We have this U-235. So it's enriched. You're enriching the hell out of it because uranium's usually element 92. So you're highly charging it. And then, yeah, from a mine or something, or somewhere in the ground. Huh, that's cool. Exactly. I actually don't think I have any lithium. I might. But anyways, back to this. This is the important part of the nuclear physics that we'll get into more next week. So basically what we're doing is we're shooting a neutron at an atom. And obviously we can't, probably not officially. So we're shooting a neutron at the center of an atom. And we're using a zirconium rod because we're not great at it. Like, we're talking extremely small distances. So what we're doing is we are shooting neutrons at these atoms, and they're just kind of bouncing around in this tube in these fuel pellets. From there, it gets interrupted because it takes on the extra neutron, and then it doesn't like it. It's unstable. So then a little bit later, we have a break. So it breaks down into more stable, because ultimately atoms always want to be more stable. They want stability, they want peace, they want calm, they want to just chill. Like, so we break down into barium and krypton, and we release incredible amounts of energy that we're bounding these two atoms together, or this atom together. So this is fission. This is fission. So fission is a breaking apart, fusion is fusing together. So we have nuclear fission, and we start breaking them apart. Krypton goes one way, barium the other way. So that breaks it down into other. And this is general fission. There are other ways to bombard it to make other particles, things of that nature. So what we hope from this is that we get these breaks. We get the energy release that releases heat, which is what we capture to make nuclear energy. We also get the gamma ray bursts, so these highly energetic particles that are coming off in the way of energies. Oh, sorry, I've been completely ignoring Rumble. What's up, Boulevard Jones? Yeah, that's what I was saying. There's different science to the electromagnetic field. Element 115. I wish we could Jesus. I wish we could synthesize that. That would be incredible. Or find it, because I think there's some interesting properties to element 115. Yes, barium is used as a contrast. So So then we're breaking apart, we're releasing other neutrons, and neutrons are further disrupting other uranium atoms that are ready to pop, and we get this chain reaction. We get this runaway reaction. That's why when you're looking at the anatomy of a nuclear fuel rod, you'll have control rods, which I believe, if I'm not mistaken, are graphite. Somebody correct me if it's not. So, or carbon. There's some form of carbon, I believe. But you'll have these control rods that are neutron. They suck up the neutrons, essentially. So you have these bouncing around, breaking other atoms, and if you don't have a way to control that, then you get a runaway reaction and it produces way too much heat. You start melting down, and you get a core meltdown, and then you get elephants put pile of plutonium at the bottom of your Chernobyl nuclear power plant that makes it uninhabitable for tens of thousands of years or whatever the current science is. So that's one of those things, and that's the runaway reaction. Yes, I believe so. Very much like thermal rods, but they're neutron receptors, so they suck up the neutrons, so the chain reaction stops. The heat, you can't really stop the heat from propagating, but you can slow down the neutrons and the reaction. So once you're done with this, then you have other elements. You have radioactive, you have the gamma rays, everything in the pool is radioactive. And yeah. Not yet, but our local nuclear power plant is the Fermi power plant in Monroe, Michigan. So, and here's another uranium fission fragments. So this is showing the percentage yield of, so this is a bunch of other stuff. About 2.4 neutrons on average, so that they can calculate how much of a reaction and how much they have to introduce to start the reaction, and then yeah, and they should be building another Fermi plant, but I don't think they're ever going to build it. But so this is the kind of energy, so kinetic energy of the two fission fragments, 168 MeV, immediate gamma ray 7 MeV, delayed gamma is 3 to 12, fission neutrons 5, gammas, betas, neutrons, and total energy released 215 MeV. So my thing is, if we could ever harness that 215 MeV, then it would be a hell of a lot better than converting it to convert it to convert it. But I'm just some asshole, so nobody listens to me. Except for you lovely people. And if you are listening to me, go ahead and hit that like and thumbs up on your respective platforms. Hit subscribe. Hang out a little bit. Yeah. Thorium is a superior physical element and safer, more abundant, and has less weapons capability. Exactly, but they want the weapons capability. They want the... It's all politics, buddy. The heat is controlled by the steam cycle. Yep. So it's all controlled by valves and all that kind of stuff outward. And nuclear reactors are much simpler than people think. Yes, so are nuclear bombs. Nuclear physics is actually... It's actually pretty damn simple. It's just when you really break it down. So, oh, you're over here now too. What's up, buddy? Yeah, that's what I'm saying. Like, I wish that we would harness the energy directly from the product of fission, but and that's one of the things that pisses me off with fusion is because we're doing the same damn thing with fusion. We're using fusion reactors to heat water. It's like, Jesus. I know that's a prove it. Like, have you ever seen the hang on tangent? This is all your fault, AP. All your fault, AP. You're gonna have to own this one, brother. It's the operation center. Where are the cooling pools? So this is the Fermi. Well, I understand that, but I'm saying if we could devise some way, no way to do it is sometimes there's a way to do things. We may not have figured it out yet, but well, yeah. I find that there's always some way of doing things, because that's the same thing they said throughout various periods of history, is that there's no way to do things. There's no way to land a rocket after you shoot it into the sky. Elon did. There's no way to access brain waves and make a monkey play Pong. Also, Elon did. Not to be on Elon's balls all the way over, but there's no way to make a light bulb. Well, that's what I'm saying. Like, there are different ways to use. I find it hard to believe that there aren't different ways to use if we put in the effort and technology to it. So this is Enrico Fermi 2. Enrico Fermi Nuclear Power Plant in Monroe, Michigan. Frenchtown, Monroe, whatever the hell they call it this week. So these are the cooling pools. And this is what AP is talking about there. The residents are concerned because, so all this is steam cooling off. So I actually don't know where the hell it's at on this one. General orientation and training. I think your reactor is, I actually don't know where it is on here, so I'm not going to misquote it. I would assume it's somewhere in this building, but it's somewhere in this general vicinity. He's not. He's an alien. So we also have, so this always has been concerning, and I understand that this water is not radioactive. It's just cooled water, but it concerns people when you look at it, and that is, I mean, like, there's Lake Erie. So people are concerned, and I understand, because ignorance causes concern, but people are concerned when they see something like this that's 15 feet from Lake Erie. And again, it doesn't make any difference that they understand or don't understand the science. It matters that it's concerning. So, well, I understand that. I'm just saying there's a different way to do it than when people see this picture, they think, oh my God, this is the nuclear material and it blah, 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 and it's going to leak into here. Oh, absolutely. And I'm very pro nuclear power. I'm just trying to see it from other perspectives. And one of the things I've heard is, oh, it's that close to the water. Well, this is just water. Well, no, it's water that's been to a nuclear reactor. No, this is just water that's coming out of this cooling tower. And you'll see some of that because of popular culture, like The Simpsons, where they have the glowing green rods and that kind of shit that comes out of. This is just this is literally a cooling tower for cooling. There is no nuclear anything happening in here. Okay. Let's do it, Beers. Exactly. Irrational fear. And I'm trying to just make it safer for people to understand that this is not the end of the world. Like, this is just very warm water that is literally cooling. So, but people get worried about it. And I understand that because if you don't know, then, oh yeah, this looks scary as hell, But they are pumping it in, like it's pumping in from here and then. Yes. Yep. Plus thorium's cool. I have some thorium too. Nuclear salt reactors. Yeah. I think that there's better ways of doing it, but than we're doing it currently, is what I'm saying. Beers, you're up by Hanford. They might have nuclear materials. Let's go get some, baby. I'll come out and visit. Thorium salt. Thorium salt. Absolutely will. Yep. Controlled explosions inside a tiny metal block. We're destructive people. Everything we build is tiny little explosions. You're a few hours from Hanford? Jacob, you're just crazy enough to do it. Beers might chicken shit out, but you're just crazy enough to do it. Here we are advocating for stealing nuclear materials from the government on YouTube. That's always great. What if I just call you guys this time? No knocks on the door. All right. All right. So that's what I'm getting to. So yeah, is it dangerous? No, but yeah, I keep trying to get my brother-in-law to give me some. Yeah, let's go. Tweety. Jude, as soon as you hit the subscribe button, you automatically become part of the list. So I'm sorry. You signed a disclaimer. But it happens. Okay, so oh god, I clicked the wrong button. If I'm not on a list, someone's seriously slipping. That's what I'm saying. Like, I'm either on a lisp or somebody is asleep at the wheel. Oh, I know you do. Are you in France, I take it, Boulevard? Or every single nuclear plant is the same? Yeah. And that's we have private companies, so you have essentially government control of how it's done. We have private companies that have competition, and it's one of the downsides that it's an up and a downside. So we both get the advancements from it, but regulation is terrible. So, yeah. Fukushima only failed because of a tsunami and the wall of the plant not being built to withstand one, and a big damn tsunami that they probably didn't think was ever going to happen, or a not on my watch thing. Oh, okay, gotcha. Yeah, I know. We're on the list as soon as we signed up the first time. Yeah, I mean, happens. Oh, gotcha. Okay. Oh, so you're already on the list. It's I'm on it. Okay, so here is this guy, and he runs through a bunch of different pictures of different stuff. I think it's cool. So we'll go into this image first. Zoomed into 100 million times. So here we go. And the Scientific American. No, I haven't. I'll look at it. Nuclear timeline video on YouTube that shows every single nuclear explosion. It's about a concerned human. That one. I'll look at that in a minute. They tell you they own you for life. Well, you're also British talking to an American, so that puts you on a list. Just collect them like baseball cards or Pokemon cards. Like, yeah, I mean, it was one of those freak accidents. So, Tweety, you know what? I don't doubt that. Tweety glows. Okay. I think it's this one, but well, so we can end this. This is image shows a photographic reconstruction of a Presnodinium orthoscandate, PRSC. So Plasmodium, scandium, and 3 oxygens. Crystal zoomed in at 100 million times. So it looks fairly unremarkable. It is an admission impish, but we already knew that. So 100 million times zoom. Not a glowy, but this is it. This is her picture, a glowing. Boulevard, I 100% agree. Like the nuclear arms race and nuclear testing, that's why there's a high premium placed on metals that were sunk under the ocean that weren't irradiated, essentially. So I think a lot of our cancers comes from that as well. So. All right, so it doesn't look that remarkable, but it truly is. It truly is to be able to see like that. Pretty insane. Trying to find a not shitty picture of this one. Article is free to registered users. I don't want to frickin' pay for your article or get it for free. I just want to read the damn thing. There we go. So this is not an actual image, but as a density image. So electrons have quantum properties, so they can be in many places at once, making it hard to image single atoms. That's superposition, and we'll get there. Before you watch the nuclear timeline, how many explosions do you think there have been? I would guess somewhere in the tens of thousands, maybe 18 to 20,000. Just out of all the testing, out of all the different, I could be way far off, but I would think that given the fact that we were doing it and every other freaking country on the planet seemed to have been doing it, but set aside power plants. Okay. So for your, I'm not sure because that's hard to parse because we use some of the reactors for, it's less, most people, it's less, but most people think they're only a few. Yeah. 1035. So that gets into that semantics part because like they have Oak Ridge National Laboratory, which is now a research laboratory, but they were smashing atoms there for all kinds of purposes. So sorry. By combining snapshots of many electrons at once, hydrogen atoms have now been imaged at 4 energy levels, increasing from A to D. So just military testing, a lot. Yeah. More than we ever should have. Look at Bikini Atoll. Okay. Yeah. Gotcha. So this gets into superposition. So it's not even that we have to it's not even that, okay, there's a nucleus and we have to we have to worry about it, and we have to figure out how to blow it up and make it big enough. Not blow it up in the literal sense, but like make the. It's not just the imaging that's a problem. There's a thing called superposition, which we'll get into as we get into the quantum physics of it coming up. So you don't actually know where it is. So it can be in all places and no places at once. Schrodinger's cat, blah, blah, blah. Things we'll get into at a later date. But yeah, so this is the best that they got with electron density. So density imaging of an atom. So we assume these are here. We have a pretty good idea they were here. The math works for them to be here. But have we ever directly seen them? No. So. Oh, yeah. And that's what I'm trying to prime people so we don't just drop quantum mechanics or quantum states on people. So we get some of the base knowledge. So it's a long. Oh, I shouldn't scroll ever. It's a bad idea. So it's a long process. I don't want to just drop superposition on them. So, yeah. So, let's go into here. And this gentleman I'm going to get rid of his audio. Well, shit, then we won't know what it is. All right, so he takes close-up pictures,
Have you ever seen an atom? Seeing as everything's made of them, you have. But have you ever seen one on its own? Over time, microscopes have become more and more powerful, allowing us to see deeper into the world of the ultra-small.
Don't worry about it,
Traditional
Jacob.
light microscopes can be used to see things like these onion cells and the structures within them as they divide, pulling apart their chromosomes. But scientists have come up with a whole host of clever methods to observe
So that image
far
was
smaller things. Using beams of electrons instead of light,
energy
we can
density
generate
image
detailed
of
images of
so it's a
chromosomes
computer
and
model.
cells. Recently, groups of scientists around the world are becoming able to see materials at the most fundamental scale, the atomic.
Yeah, it is.
One group from the University of California in Los Angeles have been getting up close and personal with nanoparticles of platinum, just a few nanometers across. Each of the tiny dots you can see here are actually individual platinum atoms. But researchers didn't stop at a two-dimensional picture. By imaging over 100 slices of the nanoparticle at different angles, then removing the noise with a special filter, they were able to map the location of almost every atom. The information was used to create a three-dimensional reconstruction of the whole particle in unprecedented detail. It may look blurry, but this particle is estimated to contain over 27,000 atoms, and so, like flies in a swarm, they appear to merge together. Every so often, though, we see the platinum's atomic structure align, granting us a moment of clarity. This technique is being used to analyze tiny irregularities in the structure of the particle called dislocations. Dislocations are subtle, like the misalignment of the green and red layers of atoms in this particle. But nonetheless, they can significantly change the properties of materials, with effects ranging from a change in the efficiency of LEDs to the strength of metal alloys. Three-dimensional atomic scale imaging like this is bettering our understanding of the structure of materials on this truly fundamental scale.
So just a cool representation. Couple things. Yes. Agreed. We know you're glowy. Stop trying to deny it. There's an uncanny valley, and that was going to be my first comment, is even though it's incredible, it's a false image. It's just a computer reconstruction. It's based on data. But it's not actually an accurate image, because it's not. So they're just computer generated and cleaned up with significant amounts of AI and different filters. It's not your typical Photoshop. But it's one of those things where pretty interesting, pretty neat. So pretty neat. Has anybody seen Ozzy in the chat? Because I have a clip for him, but he didn't show up today, and I'm upset. I've been saving this clip. All right, so where are we going next? We are going... Looking at time. All right. Just because I like him. Professor Dave. So here's his take on a history of atomic theory. So we'll pause it as generally.
Of atomic theory.
He knows a lot about the science stuff, Professor Dave explains.
These days, most people are somewhat aware of what an atom is and accept that they make up the things around us. But for a long time, atomic theory was controversial. And to understand chemistry is to understand the process by which these particles and their components came to be accepted knowledge. Democritus...
So this is just explaining the history again. So I like Professor Dave. He does pretty good work. I'm working on my intro game. I'm working on it.
Greek philosopher was the first to propose that matter is comprised of fundamental indivisible particles, which he called atomos. Though this marks the first time matter was viewed in this way, it was more of a philosophy than real science, and no supporting evidence was gathered for a long time, until John Dalton came along and provided the first empirical evidence that atoms exist. He proposed that compounds consist of different types of atoms in whole number ratios, and that chemical reactions involve the rearrangement of those atoms to give new combinations. This idea...
So, we briefly covered this in my intro of it as well. Professor told us flat out that he and his college construction nuclear weapon, and maybe you're probably less. Yeah, it's not that difficult. If I wasn't shithouse at electronics, then I could probably do one pretty quick too. I'm just shithouse at electronics. Yeah. So the timing would be all messed up. Pretty terrible at electronics. It's the one thing I'm bad at. I'm working on it though. I'm learning. So anyways, the one thing that I wanted to point out here is, again, we have an incredible amount of people that didn't even have the comforts that we enjoy as humans. We're talking about 1,000 years ago that figured this stuff out, and it's always been incredible to me that can take place. That we can... trying to kind of put it into words, that they could have come up with such... been so close. And on some stuff they were wrong, so maybe it's just a scattershot effect, and you had the world open to you so you could make different theories and some of them are bound to come true. That could have been the case, but they seem to be right on a lot more than you would have anticipated given the limits of technology at the time. So kudos to these guys for really doing the hard work.
Explained certain observations. For example, when a sample of water was split into hydrogen and oxygen, the result was always 1/9 hydrogen and 8/9 oxygen by mass. With atomic theory, this makes perfect sense if we understand that water is made up of tiny identical water molecules that all have the same exact number of hydrogen and oxygen atoms. Then, no matter how much water there is, it will always have the same ratio of hydrogen to oxygen by number of atoms and therefore also by mass. It also explained the way certain elements combined to form different compounds. If carbon reacts completely with either a certain mass of oxygen or precisely double that mass of oxygen, that probably means every single carbon atom is bonding to either exactly 1 or exactly 2 oxygen atoms. This was the first solid evidence that atoms exist. However, we soon discovered that Dalton's atoms were not the fundamental indivisible units of matter that Democritus envisioned.
Well, you have things like heavy water that kind of blow the proportion, and I think it 1 in 10 particles are. No, that doesn't sound right. It's 1 in a fraction of particles is 2 hydrogens to an oxygen. So heavy water, deuterium, blah blah blah.
J.J. Thomson showed that the atom must consist of smaller particles when he discovered the electron. In his cathode ray experiment, particles ejected from a neutral material were shown to have a negative electrical charge since they were attracted to a positively charged metal plate. This means atoms must have within them positively charged and negatively charged particles. But he did not know how they were distributed, so he proposed his plum pudding model. Just a bit later, Ernest Rutherford took it further with his gold foil experiment. He fired positively charged alpha particles, which are very tiny, at a thin foil of gold.
This one was cool. I'm going to go back 15 seconds and... Oh, shit. Maybe not. Like, and there wasn't literature for them to read. Like, they were making this up, and, you know, there wasn't Amazon to go get a cloud chamber. Like, you had to do this all yourself, and crazy.
He fired positively charged alpha particles, which are very tiny, at a thin foil of gold. He was shocked to find that almost all of them passed right through to the detector on the other side. But around 1 in 8,000 scattered wildly and with high energy in random directions. He himself said that it was as though you fired a shotgun at a piece of tissue paper and the shell bounced back and hit you. This suggested that the positive charges in the atom are highly condensed in the center of the atom, which was given the name nucleus, and that the negatively charged electrons were far away, making the atom 99.95% empty space. That's why alpha particles typically pass right through, but if they are just perfectly aligned to strike a nucleus, the huge repulsion between the positive charges makes them fly violently in a random direction. So, we arrived at a model that looks like this, which should be a familiar image. We aren't done revising our view of atomic structure quite yet, but the next chapter will have to wait for a little later in your understanding. However, certainly, we've shown that atoms exist and have proven a thing or two about their structure, which allowed for the field of chemistry to truly begin to flourish.
And that's that from a chemistry perspective, but it's also the same from other perspectives, from the physics perspective as well, for the most part. So, all right. So, hang on. Give me just a second. I'm trying not to go into the chemistry side of it as much because I don't want to do chemistry. So I'm trying to. See, it's all freaking chemistry based. I mean, I guess whatever. But blah blah blah. So that's that. All right, let's watch this time lapse video of every nuclear explosion since 1945. Jacob Castro. Shit, where's it at? Jacob.
You are fake news.
You are fake news. United States kicking it off. I'm actually going to 2 times it because it's like 20 minutes. Normal. So we're transforming the content 3, and then we wait a couple years, and then the Pacific Islands tested. No, you're a glowy, Tweety. So now we're seeing a ton of them. Math teacher fantasy. Stop it, AB. So now we're getting into the 50s, the nuclear age, and we're getting more countries on the. They tested nukes in Australia? I actually didn't know that. Yeah, see, the United States testing tons of them. It's like a damn slot machine. I feel like I just won something. Here comes France. And I love how all these European countries, and Dazzler, this is directed at you, won't test them in their country, but they test them everywhere else. Jesus. I think it's more fun at double speed, though, honestly. Yeah, we're getting up there. France nuking Africa. Younger Jamie Lee Curtis, my twin. Damn. Somewhere underground. Yeah, some underground nuclear testing. And I don't know where this runs to, but we obviously have countries like North Korea that have done it recently. I don't know if that will. Oh, I guess there's some on the bottom. China's on the bottom there. Isabella could dances. Wow. There's India coming in with their one test. You know, and it gets into where the United States. You had to play a game. How about global thermal nuclear war? Well, we might not need to wait for global thermal nuclear war. Are those live tests? No. Well, they were live at the time. Up in the upper right hand corner is a year, so 1983. So, and the other counter's going by month. So they were live at the time in 83. We might get nuclear war IRL though soon. Yep, California and Nevada screwed. So anyways, the United States has to be the nobody can test nuclear weapons because they're bad. Well, shit, you tested a lot of them. A lot of them. All right, end of the Soviet Union. Oh, it's so quiet. Totally not impacting cancer rates. That's what I thought. There's France trying to catch up. Yeah, and then there was the nuclear test ban treaties and I have India testing because Pakistan came on the map. 1998. Okay, so now it's going to break it down by country. So I just love how France just uses Africa and the Pacific. How the hell did the Aussies test a nuke on the United States soil? Look at Russia. Soviets. And here's the United States just blowing them up wherever the hell they feel like it. Wow. $2,053. Yeah, definitely not impacting anything. Yeah, oopsies. Who the worst are? At English? Not us. Yeah, the United States is uber hypocrites on this one. No, we can't. We certainly can't do that. Blah blah blah. Yeah. I don't know. But yeah, I was looking at. Here we go. This is the last one. So I have one last video, and then I was going to probably end for this evening. So one of the things that tomorrow is Wednesday. So Wednesday, we'll just take care of some housekeeping while we're hanging out here. I'll play this last video, and then yeah, yep. So one of the things that we have coming up next is we have shit, I forgot. Oh, Wednesday I'm off. I'm taking tomorrow off. And that's going to be the way moving forward. Thursday, we'll catch up on news of the week, and then we'll go over to Discord for movie night. Friday is normal build and chat. Saturday is Sea of Thieves Saturday. And then Sunday we get back into the hard hitting stuff. So Sunday, Monday, Tuesday will be more in-depth topics, and the other 3 days will be super chill, hang out for your weekend. And that's kind of how things are going to go for a while, unless something needs to change, then we'll see from there, and we'll see where we go. But yeah, that's kind of what's going on moving forward. Yes, I will absolutely check my email. Monday is Madness Monday, so we are covering the Mark Litinsky trial. Or Mike Litinsky. We're in the interview right now. He was pled guilty. There's a big thing around it, but Clinton's body counts. We're doing, like I said, that's the Sunday stuff. And this is the harder stuff, the beginning of the week. So we have kind of your conspiracy thing on Rumble exclusive. Mondays are we're covering this whole murder thing where he murdered a person that he met on Grindr, and it's pretty insane. It's been crazy. Yeah, crazy killer that likes to eat people's genitals. You forgot genitals. Part 2 of probably 5. So, yeah, Jacob's all into Madness Monday. Like, he wants a bite. So, but yeah, so that's kind of what we've got coming forward. And then, like I said, chill for the weekend. Oh, gotcha. I appreciate it. So, I want to watch this quick. It's like 4.5 minutes. It'll probably be 10 after I talk. But this puts it into context of size. So. Thank you, Jared. Oh, and animations.
What's the smallest thing you can think of? Maybe a penny or a button? How about a Cheerio? Its height is about 1/2 centimeter. For comparison,
real quick, cannibal gay guy wearing a skirt. Yes, the first guy that Tweety's not gotten thirsty about. Jacob thinks he was totally set up and he's innocent, and he's going to go meet him for a conjugal visit in prison. That's what I heard.
there are 100 centimeters in a meter. Let's go smaller, a grain of salt. This is about 0.3 millimeters. There are 1,000 millimeters in a meter. And even smaller. Bacteria are only a few micrometers. There are 1 million micrometers in a meter.
Wait a minute, what? Like now? Actual live, what? Holy shit, we might have just changed gears. Yeah, I'm working on it. I'm not seeing anything. Mystery of it crashes in Poland. The guy prepared to pick up the being dead laser. Are you talking about like a historic one? Because we've covered some UFO stuff before. I have every also the guy behind the stories on Rogan's podcast. This happened in '96. Okay, good. I was like, holy shit. So 3 days ago, from a report that I just saw, reports of large military presence and large temporary restrictions around a site following the fall of an object fueled several theories, suggesting the Polish authorities are covering up an alien spaceship crash site. Social media says UFO crashed in Poland, but well, I know, but then I'm excited. Oh, but the story is just now being broken. Well, shit. Remember that where I said I'm not gonna I can't do it tonight. But remember when I said impish that I was taking Wednesday off? That might have just changed here. No, we'll talk about it. I'll get your input before I announce anything. That's what I just said. All right, we'll get back to this video and then we'll talk. It sounds like an end wind up. Yeah, I think we're gonna start. I think we're gonna start seeing more interest in aliens and that kind of stuff. You guys know my thoughts on it. I don't think that there's any reason they would come visit us. We're not that exciting. But let's get back to this video so we can end this stream. Yeah. That's how it happens. Yes. Tweety's got it too. If aliens exist, I'd like to meet one. You can come say hi to me. We'll chat. I'm finishing this damn video if it is the last thing I do, though. We have 3 minutes left, guys. 4 minutes left. Fuck. We'll get there.
A virus is about 20 to 300 nanometers. There are 1 billion nanometers in a meter. The diameter of DNA is about 2 nanometers. The size of an atom is only a few angstroms. There are 10 billion angstroms in 1 meter. When you think of an atom, you probably picture something like this. On the outside, you've got electrons that have a negative charge. In the middle is the nucleus. It's made of neutrons, which have no charge, and protons, which have a positive charge. This model's a good starting point, but there are a few things here that don't quite agree with modern science. For one, the size of the nucleus is a lot smaller than this. If I animate it to scale, you wouldn't even be able to see it. The same thing with these electrons. Another thing that's inaccurate is that electrons orbit the nucleus just like a planet orbits a star. Unfortunately, this is still taught in many textbooks, but it's just not correct. Let me cover some background first. Over 2,000 years ago, ancient Greek philosophers had this idea that everything was made of tiny particles.
Angstroms? No, angstroms isn't a made-up word. It's a real word. It is. Science is incredible.
They called these tiny particles atoms. It wasn't until the 1800s that we finally started using science to prove that these atoms really exist. First, we thought atoms looked like this, a positively charged sphere with negatively charged electrons floating around it. Then we learned that this positively charged sphere was actually a lot smaller. We called this the nucleus. Slowly but surely, we learn that the nucleus is made up of protons and neutrons.
Anytime,
These
dear.
electrons were tricky. At first we thought, they have to be doing something, so they probably revolve around the nucleus like this. Electrons were then discovered to have different energy levels. We call these shells. Shells can only fit a certain amount of electrons. The more electrons, the more shells. It didn't take long before we realized that these
Has a
shells
bottle
help
of
determine
Frasca.
how close the electron is to the nucleus. As it turns out, electrons are a lot more unpredictable. So if electrons don't orbit the nucleus, what do they do? Let's start with an idea of an orbit. Here we have the Earth going around the sun.
Okay, just pausing it for sake of... We're all bony and not, diseased.
If the Earth is here today, we can use the laws of physics and gravity to predict exactly where the Earth will be 3 months from now. We know both where the Earth is and where it's going. Now let's go to the size of an atom. With an electron, things are a little different. We can't know exactly where it is and where it's going. We can only know one or the other at any given time. This means it is impossible to really know what the electron is doing. The best we can do is predict where the electron will be found. This area is most commonly known as the electron cloud. However, if we want to be more specific about where to find electrons, you'll need to know about orbitals. This is not the same as orbit. Orbitals are specific shapes where electrons live in. If you were in a college chemistry class, you'd be studying about how these orbitals fill up as you get more electrons. But I'd like to keep things simple for this video. So in short, electrons are uncertain. We can't know the path that they travel, only that they'll be found here in the electron cloud. So now you know that even though this is a popular way to represent an atom, it can be misleading. Just to recap what we
Very
learned,
much.
everything is made of atoms. Atoms are incredibly small. The nucleus is even smaller, and electrons don't orbit the nucleus. Their path is unpredictable. Thanks for watching, everyone.
Gravity doesn't exist in the way we think it is. Wait, what? No spiders. No spiders. Shut up, all of you with your spider bullshit. No spiders. No spiders. Because she's a picture. Yeah, that's a Boulevard. That's a whole nother episode, buddy. Supposedly the fabric of space-time. So they have no fucking clue and have to make up something so they don't sound stupid. You'll find that even though I'm pro-science and know a great deal of people in the scientific community, most of it's bullshit. The actual things that we know are so minuscule, and the rest of it is just made up to fill so they can look intelligent. What? Gravity doesn't exist. Please. No. Shut up, Tweety. Ugh. Oh, stop. No, I don't want to meet aliens. You guys wrecked it for me. Yeah, and some of it can't be proven. Like, some of it paradoxically can't be proven. Like the fact that we live in a simulation. Which I believe. You can't prove it. You can't prove it and you can't disprove it because then you're not in the immersion of the simulation anymore. So, with colors that don't even tell for sure what's somewhere. Yeah, because it's all political. And it's all how well can you bullshit. And that's why I don't like the scientific community and all the scientists and physics doctors and astrophysics, professors of astrophysics and stuff like that I know don't fall into the scientific politics. For example, there's a specific conference that I am no longer invited to because I won't get the V. So that I enjoyed attending, but yeah, I'm not about to do that still today. Because liberals have infiltrated the scientific community like they have so many other times. Well, that's a topic for another day. I actually met Neil at said conference. But would you? Yep. Oh no, I just wasn't following. I apologize. Basically we only see the surface of stuff. Yeah, and even the surface is misleading. Put your hand on the table. Okay. So if atoms are this much missing space, why can't I just put my hand straight through the table? Why won't it go? It's because there's other forces acting on it. There's strong and weak nuclear force. There's the barrier of keeping your hand from just going through, and that's ghosts. Well, good shit. We could get all on ghosts. But I can't just slide my hand through my table. Like I can punch through it and destroy it. But there's a nuclear force that holds everything together and binds everything and also repels everything that's not like or not supposed to be there. And so that's one of those things that if we're all just this wide open space with these atoms that we can, as with the gold foil, if we can pass things through them, then why can't I just pass my hand through this wall? Or why can't I pass it through this table or this chair? It's because there's more forces at play. There's the nuclear forces at play from different things that cause it, so I can't. So I agree, buddy. Just join Discord. Yes. We'll talk about it, but we might go Thursday. Might go Thursday. Yeah, but it's on a atomic level, not. Won't want a mommy magnet and a daddy magnet. Have a baby. Yep. The dark side of the force. Yeah. Belandris normally just fucks with me, so I ignore him most of the time. Who, me? No, I'm not an ICP fan. No. What the fuck? No, you said no. No. No, I'm not. God damn it. I'm gonna. Oh my god. I didn't even read it because I discount everything you say. Hang on, guys. I just got to do something real quick. It's just going to be just 1 second. Just 1 second. 1 second. And there we go. And that's good. Oh, let me get the other one too. And just gotta head over here and look for a big giant fuck. Oh, he didn't even comment on. He hasn't even commented on Rumble, so I can't time him out. Your wrenches are armed with hammers. Yes. I'm not a juggalo at all. All right, now that we got rid of Belandris, so yeah, so that's what's coming up. I'm excited about the new show format. I think it's working well. We're gonna keep plugging away at it. As always, if you have any suggestions, you are welcome to let me know. And if they're from anybody but Belandris, I will listen to them. Other than that, I hope everybody has an awesome Tuesday, Wednesday, whatever day it is for you. And hope you learned something. Hope it didn't hurt too much. And we'll keep building on it and learning more. So go out and learn something. Try something. Do something. Not currently, but yeah. Sometimes. Good. Never mind. Moment of contact event. Yeah. Yeah, there's a bunch of stuff coming in the pipeline. It was very chaotic, so we're trying to organize and make things a little bit better. So go out and learn something, go out and do something, take a chance. And yeah, I'll leave you guys with this. And we will see you tomorrow. I mean Thursday, but probably tomorrow. All right, good night, y'all.